Types of magnets. Magnets can be classified in accordance with their ability to retain the magnetic properties. There can be two types of magnets. 1. Temporary magnets. 2. Permanent magnets. Temporary magnets. These magnets can retain their magnetic properties for a short period of time. They are made of soft iron. These substances generally behave like magnets under the influence of an external form of energy such as electricity or the influence of another magnet in their vicinity. They lose their magnetic properties as soon as the magnetic effect is removed. Examples: paper clips, iron items, electromagnets, etc. Permanent magnets. Permanent magnets are generally made of steel, cobalt, nickel, or an alloy called alnico, usually by passing electricity through them. These magnets retain their magnetic properties for a fairly long period of time, even when the magnetizing force has been removed. Electromagnet. Electromagnet is based on the fact that a magnetic field is developed around an electric current carrying conductor. An electromagnet actually works on the magnetic effect of current. An electromagnet is a temporary magnet because its magnetism can be gained or lost by switching on or off the supply of electric current. An electromagnet is usually prepared by winding a large number of turns of an insulated copper wire on a soft iron. The property of electromagnetism was discovered by H.C. Ørsted. Let us perform an activity to see how electric current is used to magnetize a magnetic substance. To make an electromagnet. Activity. What you need: a soft iron rod, copper wire, battery, switch, iron paper clips. Take a soft iron rod and wrap an insulated copper wire around the iron rod. Connect the ends of the wire to the battery through the switch as shown in the figure. Now, put on the switch so that the electric current passes through the copper wire. Bring the iron paper clips close to the iron bar. What do you observe? You will find that the iron paper clips get attracted towards the iron bar. This shows that the iron rod has turned into a magnet. Now, put off the switch so that electric current no longer passes through the iron rod. You will find that iron paper clips start falling down from the iron rod. When a piece of soft iron is bound by an insulated wire and current is passed through a wire, it behaves like a magnet. This arrangement is known as electromagnet. Activity. To detect the strength of a magnet using a magnetic compass. What you need: 2 iron nails, compass needle, batteries, copper wire. Take 2 iron nails and wind the copper wire as shown in figure 1. In figure 2, the nail has more turns of the wire and the magnetic compass needle shows more deflection. Now increase the number of batteries in figure 3. The compass continues to show more deflection. Thus, we can conclude that the strength of an electromagnet depends on the number of turns of the coil along the length of the rod, the amount of current flowing through it, the nature of core material. Properties of electromagnets. 1. Even when the soft iron core is removed from the coil, the current-carrying coil behaves like a magnet. This is because the magnetism of an electromagnet is due to the current flowing through it. 2. An electromagnet is a temporary magnet. As soon as the current is switched off, it stops behaving like a magnet. 3. The strength of an electromagnet depends on the amount of current passing through the coil and the number of turns of the coil. Choice of material for the core of electromagnet. Materials that are best used for the core of an electromagnet are ones that can exhibit magnetic properties. These are 1. Soft iron core, best. 2. Metals that have a high iron content also can be used. For example, steel. 3. Cobalt, rare. 4. Carbon, rare. Scientist. Wilhelm Edward Weber was a German physicist and together with Carl Friedrich Gauss, inventor of the first electromagnetic telegraph. One of the most important works was the Atlas des Erdmagnetismus, Atlas of Geomagnetism, a series of magnetic maps, and it was chiefly through his efforts that magnetic observatories were instituted. He studied magnetism with Gauss and during 1864 published his electrodynamic proportional measures containing a system of absolute measurements for electric currents which forms the basis of those in use. Uses of electromagnets. 1. Electromagnets are extensively used in industries and scrapyards to lift heavy loads like metal scrap and machinery parts. 2. Electromagnets are used in constructing electric bells, loudspeakers, generators, and electric motors. 3. Electromagnets are used in instruments like ammeter, galvanometer, and voltmeter. 4. Electromagnets are used to separate iron and steel objects from a heap of metal scrap. 5. Magnetic levitation, maglev. These are special trains having electromagnets fixed at the base.